LogixPro Lab 2.2. So let's read the instructions specifically because I know it's a little difficult and has caused some confusion. It's asking you to write a program that will produce the following binary numbers. Look down below and you see the data tables there. Write a program that will produce the following binary numbers in input word, input 1, and output word, output 2 of the data table. We'll talk about what they mean by a word in just a second. Now they're asking you to write one rung for each output bit. So for every one of these output bits across here, you're going to write a single rung. And select either an examine if closed or examine if open of the corresponding input bit to produce this corresponding output bit. It's a lot of words. Let's figure out what all this means. So we'll go over to LogixPro, and we know that we need to create 16 rungs, or about that. I forget how many were in that data table. So let's keep inserting rungs here. If I lay down an output on this first rung here, I have the option of right-clicking on that output and going to the data table. In that data table, we see that they were talking about this table, or this word, I should say, which is 16 bits. In this architecture, it's 16-bit architecture. A word is 16 bits. So output 2, they want it to look like the series of every output needs, of the 16 outputs, we read from right to left, and we see that the output 0 for output 2, module 2, output 0 is true, 1 is true, 2 is true, 3 is true, 4 is false, 5 false, 6 false, 7 false, and the rest are false. So we're going to lay these down. So now I've got all 16 rungs. You can't see the rungs 5 through 15 because they're below here, but if I scroll, you'll see that there are 16 rungs, and it's 0 through 15 for input module 1 and for output module 2. Output module 2 has an output for each one of the 16 outputs. Input module 1 has an input instruction for every single one of the inputs. Remember, the inputs are all wired directly to these switches over here on your I/O simulator. Now we'll look at the data table and you see that input 0, input 1, 0 is seeing 24 volts or is true, and there's a 1, so we know we have to close that switch. Input 1 is false, so we'll leave that open. Input 2 is true or is seeing 1, so we'll close that switch. And the same all the way down until we'll reflect each one of the inputs being on or off all the way down through the full 16. So for 3, it's true, 0, 1, 2, 3, 4 is true, 5 is false, so I'll leave it open, 6 is false, 7 is false, and I'll just leave it there for right now. Now if we look at the input data table, they haven't changed state because we haven't done anything with this. I'm going to leave this right in the center, but just remember that there's nothing on these rungs in between these instruction sets and these outputs, these input instructions and these outputs. If I go online and download to PLC, go ahead and run, and you notice that sure enough I've got a 1 here, a 0 here, 1, 1, 1, and a 0 on the 5th. So we're following this 1, 0, 1, 1, 1. 1, 0, 1, 1, 1. All right, but now we look at the output table and they're saying they want us to get a 1 in the 0 output. Well, that doesn't agree already. They want a 1 in the second output, a 1 in the third, which is input 02. So in input 03, they want also a 1. The first 4 of these should all be true. Well, they all are except for this one right here. So how would we get this second bit in this output module to be true? Well, let's go to the data table and look at it's a 0 right now, but we could change this by going into offline and changing this instruction set to say I want to make it XIO, or examine if off, or true if off, or go look for a 0 for me to be true. Well, this is a 0 right now. This is looking for a 0, and when we download to the PLC, go into run mode, we notice now this is true, and now this is true, the output's true, because there's no falses instructions blocking this output. So now we have a 1, 1, 1, we're fine, 1, 1, 1. Well, wait a minute, they have a false here, and a false. So if we go 1, 1, 1, 1, this should be false, this is false, but what we need to do to make this a false is to actually change this instruction set. Remember when we turned all of our input switches based on, actually flip them on or off based on this input table. And if we go to the fourth input, 0, 1, 2, 3, 4, it says it's on. We want to leave it in that state to keep this data table for the input accurate. So this is on, but notice that we have then a true statement here because this is examine if closed. Sure enough, this is closed, so it's true. And it's allowing the continuity to be energizing this output. So now this is this fourth, 0, 1, 2, 3, 4, is a 1, and we want it to be a 0. So what we have to do is go offline and change this to examine if open, because now it's going to go look for a 0. And we download this and switch to our run mode, and sure enough, it's no longer true like the rest of these, it's false. It's false because look at switch 4, it's true or a 1, and this is saying go look for a 0. Well, there's a 1 there on our input, and it's not satisfying that condition, so it's a false condition, which makes the output false, which makes this fourth output in the data table false. I'll let you finish the rest of them, but that is the method of doing this, is setting all your inputs based on this data table, and then changing the and then creating one instruction for each one of those, examine if closed first, and then change those instructions based on how you want them to be true or false in order to create an output table that reflects these zeros and ones here. If you have any questions, come and see me.